Hey, learning outcome 12. I can add and subtract with negative decimals and fractions. We're still using the boxing method. This is the same deal as we did last time, only now it gets a little more complicated because we have decimals and fractions. So if we have a mystery height, and on top of that mystery height, we have 5.7 feet, and they all add up exactly to the same height as another box that is 9.1 feet tall. What's the height of the mystery box? Well, we know this. We just do 9.1 minus 5.7. We borrow 8 minus 5 is 3, and 11 minus 7 is 4. So we have 3.4. The height of the mystery box is 3.4. So let's do the math. The temperature was 5.7 degrees Fahrenheit at noon, then fell a total of 9.1 degrees Fahrenheit by midnight. What was the temperature at midnight? It's the same problem, right? It's the same problem. We start off at 5.7 above zero, so draw that box 5.7 going up from zero. 9.1 starts where the first box stops and goes down because the temperature fell. And we want to know where we end up. Well, that's the height of the mystery box. And it's 3.4 below zero. So what is 3.4 below zero? Well, that's negative 3.4. This is a very classic 7th grade math problem, the temperature problem with decimals. And if you draw it out with the box method, I think you have a great chance of being successful. Let's move on. What is negative 3 and 4/5 plus 8 and 1/2? And this is a headache. This is both computationally difficult and just kind of head-scratchingly annoying. But you can do this. You can be successful. Part about being good at 7th grade math is working through computationally difficult problems like this. So let's get some practice at it. First thing you do is you have to draw negative 3 and 4/5. So what does negative 3 and 4/5 look like? Well, it's a box that goes down from 0 and goes down 3 and 4/5. Now we go up 8.5, starting where the first box ended, up 8.5, starting from the first box ended. And if you get confused here about what you're doing, remember, it's just like 8 and 3. What if this wasn't 8.5 and 3 and 3/4? So if it was just 8 and 3, well, the mystery box would be 5 feet tall, right? Because you do 8 minus 3 equals 5. Well, that's the same thing we're going to do here. We just have to deal with the fractions. So here we go, 8 and 1/2 minus 3 and 4/5. And let's work through it. First step, get a common denominator. This should be somewhat of a review. So we need 2 and we need 5. 1/2s can't talk to 4/5, so we have to make them with a common denominator. A good common denominator is 10. So 1/2 equals 5/10 because 2 times 5 equals 10, and 1 times 5 equals 5. And 4/5 equals 8/10 because 5 times 2 equals 10, and 4 times 2 equals 8. So now we have 8 and 5/10. It's 8 and 1/2 written in different ways, 8 and 5/10, minus 3 and 8/10. Okay, cool. Now, because 5/10 is smaller than 8/10, we have to borrow. So here's how we borrow with mixed numbers. We can think of 8 as 7 plus 1. That makes sense, right? Because it's just borrowing that 1. So this 8 is going to be crossed off. We're going to turn it into a 7, and we have 1. And 1 is the same as 10 divided by 10, right? Because 10/10, if you have a cake and you cut it into 10 slices and you have all 10 slices, you have 1, or any number divided by itself is 1. So this 1 is going to be 10/10. Why did I make it 10/10 and not 2/2 or 3/3? Well, I want to use the same denominator as I have with all my other fractions. So I've turned 8 into 7 plus 10/10. So 8 is now 7 plus 1, or 7 plus 10/10 plus 5/10. And that 10/10 plus 5/10 is 15/10. So you have 7 and 15/10. 8 and 5/10 turns into 7 and 15/10. Now you can subtract 3 and 8/10, right? Because you take 15 minus 8 gets 7, 10 stays the same, and 7 minus 3 is 4. So there you go. You've turned 8 and 5/10 minus 3 and 8/10 into 4 and 7/10. Okay, so that's how you do it with mixed numbers. But But just to review, if we wanted to, we could have at our very first step turned these numbers into decimals, right? Because that's good legal math, right? So we could have said, instead of going through the exercise with fractions, we could have turned this into negative 3.8 because 4/5 is 8/10, right? And we could have turned this into plus 8.5. And that makes it easier for some people to do, and it definitely makes it more calculator friendly. So if you ever have this sort of problem and you have a calculator handy, just remember that it's good legal math to convert these numbers into decimals, the fraction part of the mixed number into a decimal in the very first instance. Although some problems are going to be a little more tricky to do that with because it's going to be like 2/3 or 1/6, which are going to have repeating decimals, which are harder to work with. Okay, let's continue on. Credit and debit problems. So a credit or deposit is equaling to adding money. If you deposit money in the bank, you add money to your bank account. If you have a credit, that's adding money. A debit or withdrawal is losing money. So deposit and debit are so similar, and you're just like, oh my gosh, why do these words have to be so similar? But credit or deposit, add money. Debit or withdraw, lose money. So after the following transactions, a student had $40 less in her bank account than she had at the start. So she debited or lost $100, earned $225.50, lost $75.25, and then lost another mystery amount. So she took out money, took out $100 in cash. She got paid for a part-time job. She took out $75.25. She bought books or whatever she bought, and then she had another purchase, and she's trying to figure out how much that purchase is if it all adds up to negative $40. Because this minus 100 plus 225.5 minus 75.25 minus x is going to equal negative 40. All right, here we go. Negative 100 plus 125.5. Combining those together, you can draw it on a number line, gets to 125.5. Then you have 125.5 minus 75.25, and that's just normal subtraction problem, you know. That'll get you to 50.25 minus x. And now it gets a little tricky. So here we have 50.25 minus x, right? Minus x, so minus this big question mark, is going to equal to negative $40. And if you draw it out using the boxing method, it's definitely going to be helpful. If you try to do this algebraically in the first instance before you get used to it, you might get confused with some of what to do with the negative numbers, which we're going to go over later in the year for sure. But if you draw it out like boxes, you'll see that's 50.25. You're going to lose a big amount, and you're going to end up at negative 40. Well, if we had this size box and this size box, and we had one box that's equal to them, it's the same as 50.25 plus 40 is $90.25. What is the value of that missing transaction? Well, x is going to equal to 90.25. And there we go. That's learning outcome 12.